The next two laws that deal with indices that we're going to have a look at is the one that looks at brackets. Now, you'll probably remember when we expand brackets, if we have a number out the front of the brackets, like 2x plus 5, for example, it actually means that we're going to multiply. So the brackets generally mean times. This is exactly the same thing that occurs with powers, but it's the powers that we are timesing, not the numbers, because it is the power that is outside of the bracket up here, not a number, excuse me, that's out the front. So if we have a look at this one, it's a to the power of 4, and then the whole thing's been squared. So a to the power of 4 is a multiplied by itself 4 times. 1, 2, 3, 4. 1, 2, 3, 4. And when we square it, that means we've multiplied this whole thing in the brackets by itself 2 times. So that's the whole thing there. That's another one of those whole things multiplied by itself twice. So if we think about counting all of those together, because they're now all multiplied together, 1, 2, 3, 4, 5, 6, 7, 8, we would end up with a to the power of 8. That is meant to look like an 8, sorry. So the other way we can think about it is that the brackets we know mean multiply. Now this time, because it is a power that's at the back of the bracket, it's going to multiply by another power. It's only the powers that will times. Unlike out the front here, it multiplies by everything and sits at the front. When it's up the back, it then has to multiply just by the things that are up the back. So if I have a look at, I could just do, 4 times 2 and get 8. If I have a look at, if I have 8a to the power of 5, all taken in brackets to the power of 3. Now remembering that brackets means times, and I'm going to multiply the powers. Now this 8, even though I've written a power 1 in there, 8 normally by itself doesn't have a power 1. But remember, if things are missing, it must have a power 1. It's not 0. If it was 0, it wouldn't exist. So it has to be one of them. It hasn't been multiplied by itself at all. It's just been done once. It's just sitting there once all by itself. So in this case, both of the powers, just like when we expand a bracket, everything inside the bracket must be multiplied by the thing outside. So that means every power inside the bracket must be multiplied by the power outside. So 8 actually has a power 1, so that will be 8 to the power of 1 times 3. The a has a power of 5, and it will become a to the power of 5 times 3. So that will give us 8 to the power of 3, because that's 1 times 3, and a to the power of 15, because that's 5 times 3. Now again, this term here, I can then evaluate because I know what its answer is on my calculator, and the word that you're doing between that step and this step is called evaluate. And all that means is because this power is a power of a number, I can use my calculator to get the final answer. So 8, again, my power button to the power of 3, and it gives me 512. So my answer is 512, a to the power of 15. The next rule, the last rule that we're going to do, and we're going to incorporate both of these into the next couple of examples and exercise that you do, is anything to the power of 0. Anything to the power of 0 equals 1. And essentially what that means is that if I have 2 to the power of 3, that's 2 times 2 times 2. 2 multiplied by itself 3 times. If what's sitting out the front of that is actually multiplied by 1. It's not 0, because if it was 0, anything multiplied by 0 always equals 0. So if I didn't have any powers, if I had 2 to the power of 0 and none of that multiplying there, what would I still have? I'd still have the multiplied by 1. So I'd only have an answer of 1. So that's why if something has a power 0, none of that multiplying has been done. What's left is just the very first number at the front, which we don't write in with algebra. We don't write times 1 or 1k or 1, 3. We just assume that that 1 sits there. So 5 to the power of 0 is 1. Y to the power of 0 is 1. But if we have a look at this one, 6 to y to the power of 0, the only thing that has a power 0 is the y. So that term becomes equal to 1. The 6 is still there. It doesn't have a power 0. 6 times 1 gives us an answer of 6. So if we have a quick look at some more examples. Examples like the brackets. Oh, I've just done that one. Here we go. Okay, so the first one is a 4 with a p0. So again, this is the term that has a 0, so it's 4 times the p with the 0 becomes a 1, and that equals 4. The 4, nothing happens to that. It doesn't have a power 0, it's just sitting out the front. The next one, we've got some multiplying to do on the top. 2, no other numbers to multiply, so the 2 stays there. X to the power of 4 times x to the power of 3 gives me a total of x to the power of 7. Remember that when I multiply, I add my powers. On the bottom, x to the power of 5 times x to the power of 2. Remember again, when I multiply, I add my powers. Now I've got a fraction that I need to deal with, which is just like divided by. And remember, we can either cancel out or minus our powers. So no numbers to divide by, so the 2 is going to stay there. But x to the power of 7 cancelled out with x to the power of 7. All of those can cancel with all of those, and it doesn't give me 0. Remember, when I take all of the powers away, what I'm left with is that 1 out the front. So it's actually 2 multiplied by 1, or just an answer of 2, because these things have cancelled out. Let's have a look at question 10. So if I have 15 over 27, again, I'm going to need to use my calculator because the number on the bottom is bigger. So using my fraction button, 15 over 27 is going to give me a fraction as my answer with 5 on the top and 9 on the bottom. There's an r squared on the top. That will cancel all the way with an r squared on the bottom. Remembering, it'll just leave me with 1, which I don't actually have to write in. S, there's no other s's on the bottom, so I need to leave the s to the power of 9 where it was. You now should be able to work on exercise 6.2, page 238, questions 1 and 2, the first column only again. I'll continue on with some more bracket questions. These, for some reason, seem to happen in the next exercise, not the one previously. Remembering that brackets mean times, so 2 to the power of 3 taken to the power of 5 becomes 2 to the power of the powers multiply. 3 times 5 is 15. A to the power of 6 all taken to the power of 0 becomes a to the power of 6 times 0, which is 0. Anything to the power of 0 equals 1. We'll have to do these individually and then multiply them together. These is a two-stepper. So 3 times 4 is going to give me p to the power of 12. 5 times 2 is going to give me p to the power of 10. When I multiply those together, I can add my powers. 12 plus 10 gives me p to the power of 22. Again, I've got to do these. I'm going to write them as a fraction, instead of a divide. 5 times 3 is m to the power of 15 over m to the power of 2 times 6 is 12. Now I can cancel. All of those 12 are going to go with 12 on the top. I had 15. 15 minus 12 is going to leave me with 3. You can now work on exercise 6.3, page 241, and I want you to do question 1 and 3, but I want this time if you can do the first 2 columns, please. So what I mean by columns is if this is the questions, and it might be A, B, C, then it might be D, E, F, G, H, I just want you, that would be the first column, this would be the second. So up here only doing the first, down here on the exercise doing the first 2 columns, please.